Okay, so the data given in this problem is the force P, red force P, that we apply. And the question is, if we know that P is equal to 100 pounds, and we know that the weight of the table is 30 pounds, what is the limit for A so the table does not tip over? And I'm sure you will all experience, like, you sit on something and it's tip over. Okay, so there is a limit for A. That's depend of P for of course. So let's draw what we know. We know the force P. I make in blue the force that I know. That's 100 pounds. And we know W. So the plate, the table is uniform, so W is in the middle. Okay. We also know, I forget to add, but we also know the diameter of the table. That's 4 feet. Okay. If we complete this free body diagram, and if you look at the table, we have 3 feet. So we have NA. Remember, we can slide the force, NB, and NC. Okay. So one thing that we need to understand is when we are looking for a force or a value at a limit, and here the limit is tip over. So when it tip over, what's happened? There's no more contact with between NC and the feet C and the ground. So NC equals 0 when it tips over, right? So we ended up having the just two unknown, NA and NB. Okay. If we look at the top view of this table, we have the table. Okay. Just imagine that it's a circle. Okay, perfect circle. We also know that the 3 feet are at 160 degrees each of them, 120 degrees each of them. So we have C, we have the center, we have B, and we have A. Okay, so 120, 120, 120. We have the force W in the middle, and we have the force P. Let's stay there. And we have the distance A. Okay, so if we look from the top, and we have NA and NB there. Okay, everything is symmetrical from this axis. Okay, let me call this axis Y and this axis X. Okay, we will use them. So everything is symmetrical. So we know that NA equal NB. Okay. We don't need to prove it if, at least for me, you do not have to prove it. If you just make this this drawing, this top view, you just say that by symmetry, NA equal NB. Okay, so we have the axis X. The axis X that I drew is there. Something like that. Okay. We will use, if we do some of the forces on the axis Z, if it's the Z, okay, we will be able to find NA and NB. So let's do some of the forces on the axis Z. It's equal to 0, because what we have on Z, we have NA plus NB, and we have minus the 100, that is P, minus the 30, and it's equal to 0. Okay, so we got NA plus NB, that is equal to 130 pounds. And because we know that NA equal NB, if we use the two equations together, we can conclude that NA equal 65 pounds and NB is equal to 65 pounds. So we have the value of those normal forces. Now the question is, what is the distance A? Okay, And with just one more equation, we can solve for that. So let's look at, we have this axis x that is there, okay? And if we do the equation of moment about x like this one, and we state that it must be equal to 0, what we have NA, NB, and P. But we need to know the minimal distance between A and the axis x, P and the axis x, and B and the axis x. So we have A, that's the perpendicular distance from between P and the axis x, but we need this distance there. Oops, the purple distance, those two purple distance. Let's call this distance D and D. That's where we need the diameter, that is 4 feet. So the 4 feet is there. We have the 4 feet, that is 2 because there's a diameter, so 2 feet and 2 feet, right? And this angle, make it just a bit bigger, just the time to speak about this angle there. Okay, we know that everything there is 120. This is a square, a right angle, but this one is 30 degrees and 30 degrees. Okay, so we have the distance D, the sine 30, that's equal to the opposite side divided by the radius, that is 2. So we got D, that is equal to 2 sine 30. This is 1. I always forget to say the D, the sine or the cosine, that is 1 feet. Okay. So now let's come back to our equation. And I will make it there. We did the equation, the first one, Z, and now I will do the sum of the moment about the axis x. It's equal to 0. So W is on x, so it doesn't create any moment. We have P, if we look, oops, so that's x, y, and z. So P tend to rotate in the positive direction. So we have P times the distance A, and A tend to rotate in the negative direction. So minus NA times the distance D, and B tend to rotate in the negative directions too. So minus NB times D is equal to 0. So we have P times the distance A, that is equal to NA D plus NB D. P is 100. A is the unknown. NA is 65. D is 1, and 65 and 1. So we ended up having A that is equal to 130 divided by 100. This is 1.3 feet. So the limit for A, this limit there, is 1.3. So it's a bit more after this one, 1.3. Make sense? So if you have your table, oops, the total is 2. Those one on the side are there, the feet are there, and we do have the weight, and we can go up to 1.3. So something about there, and that's the force P, 1.3. After that, we tip over. That's funny because you see we can go a little bit after, but not so much. And of course, that's depend of the force P, the weight of the table, and how your feet are, how they are spaced around the edge of the table. So that's it for this one. That's why we have 1.3 feet. See you in the next video. Bye bye.